Hi, Kat here for Lightwave Digital. In this video, we're going to be talking about how various textures can be applied to various types of models using simple projections. What I mean by projections is that there are built-in methods of projecting a texture around a surface of an object. So let's get started. Here, let's take our ball. We've got this ball from our standard photographer's cove that we built in a previous video, and we're going to apply a texture to it. Just giving us an idea, we're going to use a standard material, which is the old Lightwave system. These are an emulation of the old shading system that was in Lightwave from Lightwave 4 to Lightwave 2015.3. So this is an emulation. If you're going to be working in any of the other standard shaders that are the new photoreal shaders that are physically based, then this will still seem somewhat similar, but there are some caveats to that. So let's just keep things basic, and we'll work with the blue ball with the standard material, and we're going to apply a texture to it as a image. Now, I have some really nifty images here that we can load and apply to some of these objects. So let's take a look at those. I'm going to hit load on the image editor, and I'm going to load up all of these. Now, I'm not going to use everything on this one particular ball. I just want this really nice Mars texture that I've got. So let's go in here, and we notice that in the texture editor, we've got a default set of settings once this comes up. We are going to use an image map. We need an image map to work with, and we have a projection type. There are a few projection types that we're going to be dealing with today. Primarily, it's going to be planar, cylindrical, spherical, and cubic. We're not going to worry about front or UV for now. That'll be in another video. Let's take a look at spherical, because this is a ball. Obviously, it's a spherical shape, so we can use that. And we need a texture, which we will use our Mars. And there we go. We've got it. Thing is, though, this has an axis to it, and the z-axis may be fine in some cases, especially if it's a sphere. It really doesn't matter. But for our purposes, we want the pole to be at the top of the sphere, because if we look at this, we'll have a geo wireframe, and we go and select that sphere. That's where our pole is, so that's where it should align to. Keeps things logical in an animation sense, and just for direction, helps keep us oriented properly. Now, we don't really have to do anything else with this. It is applied this texture map. Because it's a sphere, it's going to wrap it 2:1. And we can scale up or down. Doesn't change its orientation or positioning of the sphere, the texture on the sphere. And when I made 2:1, for a sphere, you need to have a map size of 2 times the height. So this is 2 times wider than the height, and that'll ensure that it wraps around nicely. Though there's more to this, so let's copy this layer and go into the bump map down here, and we'll just paste it in, and we'll replace this Mars AK with the bump map that goes with this. And there we go. And now this thing has bump to it. I'm going to turn the OpenGL overlay off here so we can see it a little bit better. And you can see that if we get closer in with the camera, there's bumping taking place on this, and it's sort of catching shadows. But you have to understand that bump mapping is a fake. It's an approximation of what light might do in a scene with something that has a bump map applied. It's a very old technique in computer graphics. It was developed in the late 1970s, and it works beautifully on a lot of different distant objects where you're not going to see a lot of that detail close up, or even close-up objects with some refined settings. So, for example, the bump height, we could crank this up to 500. Now, this may make it look a little bit funky, but you can see that it's a little bit more dominant. Now, it's not actually pushing geometry out of the top where there'd be, a mountain or something like that. It's just taking the calculations of light and giving us a rough approximation of what the bumpy surface would look like. Let's crank this up a little bit more. Go into that texture and really crank it up. So we have a texture amplitude in here. So we'll go to 2, 3. We'll start to see it come out here on these areas. Let's go 5. 10. And so forth. Changing the light will obviously make it more prominent. And this is important to note because bump maps are effectively going to work with light in a full evaluation manner. But there's another method for applying like a surface detail deformation without a full evaluation in the renderer. And that is through the use of a normal map. Now we have a different object for this that we're going to use. So let's move on to a different object. We're going to just back out again. And we're going to focus on our purple sphere here. All right, so purple sphere. Okay, we've got, or the purple cylinder, pardon me. Let's take a look at its texture. For this one, we're going to use a cylindrical map, or pardon me, cylindrical map, and we're going to use a tire. Okay, and we can see right off the bat that this is all kind of wonky, and the reason for it is we need to correct the axis that it's applied on. So we're going to try X, maybe Y, and then we can hit automatic sizing. And there we've got, an axis with, or the tire texture on here. We're not going to worry about the top of the cylinder right now. We would have to do a couple of corrections in Modeler to adjust that so that it has a different surface. But for right now, this is going to be fine. And now that we've got that, let's go into the node editor really quickly. Just minimize this right out. And we're going to go and apply a 2D image called normal map. And we're going to use this tire NM. And we're going to use basically the same settings over here. So texture map axis is going to go cylindrical, automatic sizing. Make sure that that map is plugged into normal. And now this gives us a normal map. Now, alternatively, because we can see these types of maps in OpenGL, we can reroute this a little bit. And now we've got a normal map applied to it. Let's make sure that I've got this applied correctly. Let's invert that for a second. And let's go pump this into here instead. Okay. Let's turn VPR back on. Let's move this stuff out of the way. Now, what a normal map is it's basically a pre-calculated bump map. And if you look at these different colors inside of the image, these provide a method of light when traced through the ray in the ray tracing engine to be told to go in a certain direction. It's pre-calculated, so it's not the same as a bump map, and it's actually quicker to use normal maps than it is bump maps. However, they can be combined. This will just give a appearance of material having a surface to it. It's got like some texture or some tooth. Again, though, it is not a true replacement for deformation on a surface. It's just there to give us the appearance of it having some kind of indentation or rise out of the material. Let's recenter our camera here. Let's take our box. All right, same operation as before. This one's going to be different. We're going to take this and set it to cubic, because that's what a box is. It is a cube. And we're going to work with something like the segment plate color. And you get a little kind of mini Borg cube here. Again, didn't really have to do much. You didn't have to automatic size it, although we can. And you'll see that the texture will stretch out. This was set to be a 1 meter by 1 meter cube, so it's not going to do much. But we can see that it wraps itself all the way around, and it does a really good job of doing so because it knows where the edges are, the tile width and tile repeat. So we can take this object. Oops. Let's take a look at the actual cube, which is no longer a yellow box. But we can see that the texture is applied all the way around. It's evenly spread out. And we really didn't have to do much work there. Let's make this a little bit more pretty looking. Let's copy this and go into the specular channel for this, paste it in, and we'll change this color to spec. And now we're getting a box with some specularity mapping applied to it. Now we may have to do a change of the blending mode to make this really work very well. But we'll just reorient our box, and we can now see specular shine from our light source bouncing off the side of it. So let's try a version of this. Let's go alpha and give ourselves a 50% value there. And you can see that this is now very metallic looking. Let's invert that layer. We can use additive. So wherever there's a bright value, it'll mask it out. Wherever there isn't a bright value, it'll pass through. So black being total pass through, and white being a mask. Now there is one more to this, which is the bump map. So again, we can click bump. Got to bring the editor in here. We're going to hit paste, and we're going to change this to bump. Okay. And now we can see that this has got lines in it. We'll just turn that off really quickly. The lines are not very defined, but once we turn this on, you can see that they pop on. And this is just a simple bump mapping approach. Again, if we take a look at this image, you'll see that it's literally just dark lines or semi-dark lines over top of white. So wherever there's black or a tone lighter than full bright white, you will get a kind of indented texture. Now we can flip this so it goes the other direction. And now those lines seem to have been formed on the surface. They're not etched in. It's the other direction. Just by flipping the direction of the map. Typically, bump maps should be additive, so that whatever your value is underneath, you're going to be adding more value to it. Although if you've only got one bump map in there as a texture or an image, it's fine to just apply it in normal mode. Or if it's the very base and you want to create another layer on top, let's take a procedural Let's squeeze this into the box space, and we'll go multiply. See that it has a little bit of bump there. We can decrease this, make it more prominent. Set that texture value to 100%, 50, and you can see that it's got more tooth to it. So basically, by setting this to multiply, we're multiplying whatever these values were. And right now, there isn't much to the base of that, so you might want to hit additive. So there it is with additive, and you can see how this has transformed the look of it completely. And we can dial this back. If you look at the top edges of this object, you'll see that that bumping isn't prevalent. And it's because it's a fake. It is a cheat in 3D to give us some form of raised surface or indentation off of a map. All right, let's put this object back to where it was. Okay, and let's take a look at our cylinder here. When in VPR, you can shift click and the surface will come up in the surface editor ready for you to edit it. This is not possible in the other modes, however, so if you shift click this or shift click that, you're not going to get anything except for selections of those objects that you're clicking on. So just keep that in mind. Let's go to that cone, and we're going to go and either apply a texture here or through the traditional T's that we can over here. Let's do one from this side though, just as practice, because we need to get used to nodes. Nodes are a good thing. And we're going to go and hit the image editor or the images. We're going to double click on that so we can bring up the image selector. You'll see that this is quite different than the other ones from the T bar. It's just a different way of looking at something like this. So let's take a different map here. Let's go with Hangar Bay Recessed. This is a light cookie actually, but we're going to use it for something different. It's just a shape that gets projected through lights normally, but we're going to put it on our cone here. So we're going to, for this, use Cylindrical because this is the most predominantly cylindrical shape, and we're going to hit Y, and we're going to hit automatic sizing. We need to see what we're doing though, so let's turn on VPR, and we'll wire this into color, and now we have this shape projected onto our cone. It might not be the right axis though. Let's try the other ones. There's Z, there's X. That was probably why it just needs to be automatically sized. We could also use planar as an option, because this will project literally from the top down onto the cone. And because it's a circle, in terms of its shape, it works really well there. All right, now, when we take a look at these as they are in camera, we're seeing various properties applied to them. There's nothing wrong with anything in here. We're just looking at it as a demonstration, but there's another back end kind of look to how you can see these things, and that is how their surface properties are reflected in the buffer system in Lightwave. Now, I'm not going to get too much into this, but we do have some functions in here that could be really interesting for you to take a look at a later date, and we will have full tutorials on this. So here's the full raw RGB. So no lighting, just raw color. There's no reflection in here, even though Some of these surfaces may have reflection. They're going to be represented in specular direct, specular indirect. Now, some of these buffers are not going to be active because there's nothing surface-wise that will contribute to it. There's a tangent space, which is something that we'll get into in the future. And let's take a look at depth. Now, this is basically a special type of buffer that if we normalize the display, we can start to see the depth of our images. Now, the reason why it's white all the way through to the background is because we have this cove. And this cove, if we just hide it for the moment, you'll see something very different. Let's go to the scene editor. Okay, we'll just turn that off for a second. You can see that we've got the outline of the shapes. Now, the normalized display on, we can see those shapes. With the normalized display off, we don't. And the reason why it's because it's a high pixel depth buffer and it's going from 0 to infinity, and to normalize it, we're just basically taking those values and pushing them into something that can be realized on the monitor. Now, this is going to be important in one of the next tutorials for this, because we're going to do two different types of depth of field trickery. So we'll get to that in the next video, and we'll see you really quick.